The Polar Satellite Launch Vehicle, commonly known by its abbreviation PSLV, is an expendable launch system developed and operated by the Indian Space Research Organisation. It was developed to allow India to launch its Indian remote sensing satellites into Sun synchronous orbits, a service that was, until the advent of the PSLV, commercially available only from Russia. PSLV can also launch small-size satellites into geostationary transfer orbit. As of 2014, the PSLV has launched 65 satellites/spacecrafts into a variety of orbits. Some notable payloads launched by PSLV include India's Chandrayaan-1 lunar probe and the Mars orbiter mission. It is the most successful launch vehicle in ISRO, till date, with 25 consecutively successful flights out of 26 launches. Development equals, PSLV was designed and developed in the early 1990s at Vikram Sarabhai Space Center, Thiruvananthapuram, Kerala. The inertial systems are developed by ISRO Inertial Systems Unit at Thiruvananthapuram. The liquid propulsion stages for the second and fourth stages of PSLV as well as the reaction control systems are developed by the Liquid Propulsion Systems Center at Mahendragiri, Tamil Nadu. The solid propellant motors are processed at Satish Dhawan Space Center, which also carries out launch operations. After some delays, the PSLV had its first launch on September 20, 1993. Although all main engines performed as expected, an attitude control problem was reported in the second and third stages. After this initial setback, ISRO met complete success with the third developmental launch in 1996. After a partially unsuccessful launch in 1997, further successful launches followed in 1999 and 2001. PSLV continues to be the workhorse of Indian satellite launches, especially for LEO satellites. It has undergone several improvements with each subsequent version, especially those involving thrust, efficiency as well as weight. In November 2013 it was used to launch India's Mars orbiter mission into an elliptical orbit around Earth. Mars orbiter mission is India's first interplanetary mission to planet Mars with an orbiter craft designed to orbit Mars in an elliptical orbit. Vehicle description: the PSLV has 4 stages using solid and liquid propulsion systems alternately. The first stage is one of the largest solid-fuel rocket boosters in the world and carries 138 tons of hydroxyl-terminated polybutadiene-bound propellant with a diameter of 2.8 m. The motor case is made of maraging steel. The booster develops a maximum thrust of about 4,430 kN. 6 strap-on motors, 4 of which are ignited on the ground, augment the first stage thrust. Each of these solid propellant strap-on motors carries 9 tons of HTPB propellant and produces 677 kN thrust. Pitch and yaw control of the PSLV during the thrust phase of the solid motor is achieved by injection of an aqueous solution of strontium perchlorate in the nozzle to constitute secondary injection thrust vector control system. The injection is stored in 2 cylindrical aluminum tanks strapped to the solid rocket motor and pressurized with nitrogen. There are 2 additional small liquid engine control power plants in the first stage, the roll control thrusters, fixed radially opposite one on each side, between the triplet set of strap-on boosters. RCT is used for roll control during the first stage and the SITVC in 2 strap-on motors is for roll control augmentation. The second stage employs the Vickers engine and carries 41.5 tons of liquid propellant on symmetrical dimethylhydrazine as fuel and nitrogen tetroxide as oxidizer. It generates a maximum thrust of 800 kN. Pitch and yaw control is obtained by hydraulically gimbaled engine and 2 hot gas reaction control for roll. The third stage uses 7 tons of HTPB-based solid propellant and produces a maximum thrust of 324 kN. It has a Kevlar polyamide fiber case and a submerged nozzle equipped with a flex-bearing seal gimbaled nozzle thrust vector engine for pitch and yaw control. For roll control it uses the RCS of 4th stage. The 4th and the terminal stage of PSLV has a twin-engine configuration using liquid propellant. With a propellant loading of 2 tons, each of these engines generates a maximum thrust of 7.4 kN. engine is gimbaled for pitch, yaw on roll control and for control during the coast phase uses on-off RCS. PSLV C4 used a new lightweight carbon composite payload adapter to enable a greater GTO payload capability. PSLV is developed with a group of wide-range control units. Variants: ISRO has envisaged a number of variants of PSLV to cater to different mission requirements. There are currently 3 operational versions of the PSLV: the standard, the core alone without the 6 strap-on booster motors, and the version, which carries more solid fuel in its strap-on motors than the standard version. All the 3 versions have proved to be unalloyed successes. These configurations provide wide variations in payload capabilities ranging from 3,800 kg in LEO to 1,800 kg in Sunday's synchronous orbit. PSLV: the standard version of the PSLV has 4 stages using solid and liquid propulsion systems alternately and 6 strap-on boosters. It currently has capability to launch 1,678 kg to 622 km into Sun synchronous orbit. PSLV-CA, the PSLV car, CA meaning core alone, model premiered on April 23, 2007. The CA model does not include the 6 strap-on boosters used by the PSLV standard variant. 2 small roll control modules and 2 first-stage motor control injection tanks were still attached to the side of the first stage. The 4th stage of the CA variant has 400 kg less propellant when compared to its standard version. It currently has capability to launch 1,100 kg to 622 km Sun synchronous orbit. PSLV-XL: PSLV-XL is the uprated version of Polar Satellite Launch Vehicle in its standard configuration boosted by more powerful, stretched strap-on boosters. Weighing 320 tons at liftoff, the vehicle uses larger strap-on motors to achieve higher payload capability. FSOM-XL uses larger 13.5 m, 12 tons of solid propellants instead of 9 tons used in the earlier configuration of PSLV. On December 29, 2005, ISRO successfully tested the improved version of strap-on booster for the PSLV. The first version of PSLV-XL was the launch of Chandrayaan-1 by PSLV-C11. The payload capability for this variant is 1,800 kg compared to 1,600 kg for the other variants. Other launches include the RISAT radar imaging satellite and GSAT-12. PSLV-HP, as reported on the website of the New Indian Express newspaper, PSLV project director N. Narayan Amathi spoke of another version being planned called the PSLV-HP, standing for a High Performance unregistered trademark. It will have improved strap-ons motors, and the payload capability will be raised to 2,000 kg. The HP version will be used to launch a constellation of 7 navigation satellites between 2010 and 2012. Among other things, the efficiency of the Stage 4 engine will be improved in this version. PSLV-3S, ISRO is also considering the development of a 3-stage version of the rocket without 6 strap-on boosters which will be capable of placing 500 kg to LEO. Launch history: as of June 30, 2014, the PSLV has made 27 launches, with 26 successfully reaching their planned orbits. All launches have occurred from the Satish Dhawan Space Center, known before 2002 as the Sriharikota Range. Planned launches, notable flights. PSLV Flight D1, this was the first developmental flight of the PSLV D1. The IRS-1E satellite which was proposed to be launched was derived from the engineering model of IRS-1A incorporating a similar camera and an additional German-built monocular electro-optical stereo scanner. Even though the mission was a failure, the launch team and an expert committee appointed thereafter noted that the mission had validated many technologies and that most subsystems has performed optimally. PSLV Flight C-1, the launch was witnessed by the former Prime Minister I. Kejriwal and also marked India's first launch vehicle built without Russian assistance. PSLV Flight C-2, in the flight sequence, IRS-P4 was injected first, followed by Kitsot-3 and Eula-Tubsat in that order. The mission was supported by a Stark network of ground stations located at Bangalore, Sriharikota, Lucknow, Mauritius, Bes Lake, Russia and Biak, Indonesia. During the initial phase of the mission, the ground station at Wilhelm in Germany also provided network support. Upon injection of the satellites, data from the IRS-P4 was received at Hyderabad, while Kitsat-3 data was received at the ground station in Korea, and the data from the TUBSAT was received at the University ground station in Berlin. PSLV Flight C5. The launch took place despite heavy rain which commenced half an hour before the scheduled launch. However, ISRO decided to go ahead with the launches despite rain. There were no strong winds and there were weather reports suggested that the monsoons would set in by the next day. Following the launch, a press statement released by the Minister of State announced that the PSLV has been proposed for the Chandrayaan-1 moon mission. PSLV Flight C6, the former president, Dr. Abdul Kalam, witnessed the launch from the Mission Control Center. It was the first PSLV launch from second pad, using integrate transfer and launch technology. After its integration in the vehicle assembly building, the PSLV C6 was transported on rails to the umbilical tower located 1 km away using the mobile launch pedestal where the final operations were carried out. PSLV Flight C7, the following hardware changes were made since PSLV Flight C6, first use of DLA to launch 2 primary satellites in time, reduction of propellant from 2.5 ton to 2 ton in the 4th liquid propellant stage, incorporation of a video imaging system to capture payload and DLA separation events, altitude-based day of launch wind-biased steering program during open-loop guidance, removal of secondary injection thrust vector control system for one of the strapons ignited in the air. PSLV Flight C9, the 4th stage first fired Cartosat-2A into orbit at an altitude of 637 km about 885 seconds after liftoff. About 45 seconds later, it propelled IMS-1 into the orbit. Then the 6 nanosatellites belonging to a cluster called NLS-4 were injected into orbit at intervals of 20 seconds each. NLS-5, a single satellite, flew out and finally the 10th satellite Rubin 8 went along with the 4th stage into orbit. 2 satellites belong to India and the remaining were nanosatellites built by universities in different countries. PSLV Flight C-21, launch attended by the former Prime Minister Manmohan Singh. Resins bolted to the vehicle's 4th stage, have tested avionics for future PSLV missions. PSLV Flight C-22, earlier launch date for PSLV C-22 was fixed as June 12, 2013, but the launch had been postponed because of a technical snag in the 2nd stage. The launch of the first satellite in the Indian Regional Navigation Satellite System of the Indian Space Research Organisation, scheduled for June 12 from Sriharikota, has been postponed by 14 days after an anomaly was discovered just 11 days before launch. The satellite IRNSS-1A, which would be the first in a series of 7 navigation satellites, was scheduled to be launched on board the Polar Satellite Launch Vehicle C-22 at 1.01 am on June 12. The satellite has undergone its pre-launch checks successfully. However, ISRO said the launch vehicle had an anomaly in one electro-hydraulic control actuators. During the electrical checks of the launch vehicle, an anomaly was observed in one of the electro-hydraulic control actuators in the 2nd stage. It has been decided to replace this actuator, a statement by ISRO said. Officials added that the replacement of the actuator would take 2 weeks and it would be carried out at the launch pad and vehicle assembly area. ISRO then replaced a faulty component in the PSLV C-22 rocket and rescheduled the flight of the IRNSS-1A satellite on it for 11:41 p.m. on July 1. PSLV C-22, successfully launched IRNSS-1A, the first satellite in the Indian Regional Navigation Satellite System. At the completion of the countdown, PSLV C-22 lifted off from the first launch pad at 23:41 hours July 1, 2013 with the ignition of the first stage and 4 strap-on motors of the launch vehicle. PSLV Flight C-25. The Mars Orbiter mission, informally called Mangalyaan, is a Mars orbiter that was successfully injected into Earth orbit on November 5, 2013 at 2:38 p.m. IST atop a PSLV-XL launch vehicle from Satish Dhawan Space Center, Sriharikota. PSLV Flight C-23. PSLV C-23 was launched at 9:52 a.m. IST on June 30, 2014. It carried 5 foreign satellites: Spot 7, NLS 7.1, NLS 7.2, ISAT and VELOX-1. All 5 satellites were released successfully. The launch was attended by Prime Minister Narendra Modi, the 15th Prime Minister of India. He mooted the idea of a SAARC satellite as India's gift to the region. The liftoff time was originally planned to be at 9:49 a.m. IST, but was later rescheduled to 9:52 a.m. IST due to debris getting in the trajectory. Launch failures. IRS-1E. On September 20, 1993, a PSLV D-1, the first developmental flight, rocket failed during launch. A significant attitude disturbance occurred during second to third stage separation, causing the attitude control command to exceed its maximum value. Because of the programming error in the pitch control loop of the digital autopilot software in the guidance and control processor, the required reversal of command polarity did not take place, causing the pitch loop to become unstable, resulted in loss of attitude control and failure to achieve orbit. The attitude control disturbance was traced to failure of one of the retro rockets designed to pull the burnt second stage away from the third stage. The vehicle crashed into the Bay of Bengal 700 seconds after takeoff. IRS-1D. On September 29, 1997, a PSLV C-1 rocket failed during launch. Anomalous interaction between the primary and secondary pressure regulators of the fourth stage caused a reduction in propellant flow and thrust after 250 seconds of burn time. As a result, the fourth stage was shut down by a software override timer after burning 435 s, before reaching the target orbit or depleting propellant. The injection velocity was 140 ams low, resulting in an orbit of 301 x 823 km instead of the planned 817 km circular SSO. Initially, a leak of helium gas from one of the components in the fourth stage was suspected, similar to recent Long March 3 launch failure, but later ruled out. Resulting orbit was partially corrected using satellites onboard thrusters, thereby raising the perigee to 737 km, while the apogee remained at 821 kms. See also, geosynchronous satellite launch vehicle, comparison of orbital launchers families, references. External links, ISRO Space Exploration, PSLV Moon Missions Launch, PSLV C-7 Launch Video, ISRO PSLV page, Bharat Rakshak PSLV page, India in Space PSLV page, PSLV C-8 Mission Photo Gallery, RISAT, News on PSLV C-15 Success.